Okay, so in our last lesson, we learned that if you have two triangles and they have three sides in common that are the same or congruent, for example, this side has one dash, and over here this has one dash, which tells us those sides are equal in length or congruent, and two dashes and three. So we know that if two different triangles have three sides in common, they are congruent by the principle of side, side, side. And there was other things we looked at as well that also would tell us that they're congruent, side, angle, side, etc. So when the symbols are given directly and we know the principle, then we can determine it equally. But what happens if the evidence or the proof that they're the same is not given directly, but indirectly? So that's what we're going to study today. And usually it's going to be based upon some geometric principle, a lot of times that we've already learned, that allows us to conclude that they're going to be, two sides, for example, or two angles are going to be equal. So that's what we're going to be learning about today. Okay, so let's start by going to page 4. Page 4 is giving us some things that we've already learned about, but that we're going to review, and we're going to help to use to figure out whether triangles are congruent. So a key thing we're going to learn about or review and make sure we do when we take our notes is talk about how we should mark up a diagram or a figure to help us figure out what additional evidence we have. In other words, to go from having something that is indirectly given to something that is directly given, kind of like we saw the dashes on a triangle. When we see that, we say, oh, okay, it's directly, these two sides are congruent. Why? Because they're marked. We see it. It's directly given. But what happens when we get clues that allow us to figure out something? That's what we're going to talk about. And then so what you do is you mark off your diagram so that it goes from being indirect to direct. Let's look at the first one here. So midpoints. So what they're saying here is given. That means given that M is a midpoint of AB, what can we figure out from that? So if that's a midpoint, what can we figure out from that? Well, if it's a midpoint, that tells us that this segment from AM is congruent to this segment. So we should mark it like that so we can see it. And then what would we write down? We'd write down AM, it's a segment, so just like that, congruent symbol like that to B, or BM or MB, and then we would mark it like that. So that's what that allows us to figure out. That's how you mark it, and that's the congruency statement. So now let's go to the next one. Okay, so here the given one is telling us MO bisects, that's ray, right? It's a line that extends with an arrow. It bisects or cuts in half the angle AMC from A to M to C. So it's the wider angle, not the little narrow angles. But if MO is bisecting, it tells us that it forms two new angles like that. So we put the angle symbol, and then we put like a little dash to show that those are equivalent angles. And then we can put that angle AMO, is congruent to OMC, and I should put angle there. You should put angle there, okay? So that's what how we mark it, and that would be the statement, okay? The next one, AB bisects CD, so AB bisects. Now this is really important. AB is cutting something in half, which means that CD is being bisected by AB. So that means CD, we can confirm that this CD is cut in half so that this segment CE is congruent to that. But it doesn't say that AB is being bisected. So we can't say that this segment is equal to that or congruent to that. A very important difference. So CD is getting bisected, or AB is cutting it in half. So that tells us, again, those are the markings. So CE congruent to ED. Okay. Next, reflexive property. So reflexive property, think about it like a mirror. When you look in a mirror, what do you see? You see yourself, right? So the same thing you see over here, you see over here. It's the same, right? It's congruent, really, because it's not literally the same, but it's a reflection of it. What does that mean? It means that one thing is more than one thing at once. So XY is just XY. It looks like it could be the same as XZ, but we don't know. But it's definitely a different side. This side is different than that. XZ is below it, right? But what they do, if you look at this figure, you see that it's actually three triangles, two smaller and one big one. And the smaller ones have something in common. They have the middle line. In other words, a triangle is formed by 3 lines, 3 sides, right? Well, these 2 triangles are formed by 3 sides, but one of the sides they're formed by, XM, is something that they have in common. We call that, what that means is we mark that with a symbol, okay? So let's put the symbol there. And then we say that XM is congruent to XM. Now you might say, well, that doesn't make any sense. It's like saying 5 is congruent to 5. Well, it is. But anyway, that's how you show the reflexive property. That's the symbol and that's that, okay? Okay, so the next thing is here's a few other ones that we can look at. So vertical angles, we should know that basically if we've got a marking like this, we can conclude, because of vertical angles, that those two are equal. So we would say the statement would be what? ABE is congruent to, and remember I got to put the symbols there, CBD, right? So those two are congruent. Perpendicular, you could say, so if we know that that's 90, then this is going to be 90 as well. So that would mean ABC perpendicular to angle CBD. Okay, corresponding, what does that mean? Well, it means that angles, if we got parallel lines, like all 3 of these are the example of that, that means we can make a conclusion that angle Y is congruent to angle X for this one. Here, alternate interior are going to be equal as well. So angle X is congruent to angle Y. Here, alternate exterior are equal as well. So angle X is congruent to angle Y. Okay, so we're going to be using all these principles when we're given indirect information to make them direct by taking information like that and saying, okay, or let's just look at the vertical. If we have vertical angles, but they don't show the symbols there showing that these angles are true, then we can take the clue, think about those as clues, indirect clues, and say, well, if this is true, we know that this statement must be true, and it becomes a given reason. And that's how you're going to justify or prove that 2 angles are congruent. And like I said in class the other day, you can't just say, hey, they look like they're the same, so they're the same. You've actually got to use geometric principles to prove that they're true. And this is how we go about doing that. Okay, so now you're ready to do the assignment for today, thinking about these various principles that you're going to be using.